Okie dokie. For starters, and I'll put this as an announcement as well. Next Wednesday, so a week from yesterday, um, uh, there is a kind of a student pitch event in the AI and Quantum Innovation Labs on the main floor of the business building. Um, uh, so we're going to have lots of business analytics students kind of pitching their projects. So you kind of get to see what students are working on here. We have a couple of computer science students who are doing a pitch. The reason I'm super strongly recommending everybody come to this is you get to see kind of the types of projects students are working on and how you can get involved. I mean, we even have freshmen working on some projects in the lab, but now you're getting some skills that are going to let you benefit from it. Um, I'll have a sign up sheet if you show up to this event in person from 6:30 to 7:30 p.m. next Wednesday in the business building. I'll give you 10% extra credit in your final exam. That's a pretty good ask. We want to make sure there's people there. So write it down, show up, and get the bonus points. And remember, your final exam could help your midterm exam if you did crappy on it. So I'm giving you an extra 10% there. So it is a bribe, is what it comes becomes. That is a full-fledged bribe. No, it is 100%. I care more about your participation here than your grade because I think grades are stupid. I think learning is important, but I think grades are stupid. Okay. So everybody have that date down, November 3rd, or November 5th, next Wednesday, 6:30 p.m. to 7:30 p.m. It's only an hour down in the business building. 113, which is the AI and quantum lab. There's a big sign on the outside of it.
About AI.
Huh? There will be projects dealing with artificial intelligence as well as projects talking about quantum computing. So I'll be presenting my big government grant that I'm working on with the Department of Defense with quantum stuff. So that's the project that's like funding the lab. So we have I guess, $2 million a year grant with the Department of Defense, and that's where the money that is buying all the supercomputer stuff for the lab and stuff is coming from. These are the types of things that students really should get involved with at universities, and for the last 15 years, they don't get involved with. So maybe be the first group to step up, but giving you a lot of extra credit. So take it or leave it. I also have found students don't care about their grades that much either anymore. So who knows how good of a bribe this ends up being. So I think it's a great bribe, but realistically, you might not need the extra credit in your final exam. That's what always happens. The students who show up to the stuff are the students who already are getting an A. So then they end up with, I got 107% in the class, so it actually cost me nothing, right? Except I had to go in and, Banner will complain when I submit the grades that it's something above 100. And they'll start yelling at me. I one time failed a student because he had like 113%. And Banner didn't know what to do with it. And I was lazy because it brings the grades in. I was going through, oh, they all look fine. They look good. So it's like top student in the class. I got an F. It's like, what did I get on the final? All right. And I'll put that into an announcement as well. I'll probably keep hitting you with this over and over again just to remind you, but please get it in your calendar. I think it'll be a good event too, so it'll actually benefit you, but I'm willing to pay you to come to it. Let's go that route. All right. So last class, we were spending quite a bit of time kind of putting Java and Python right next to each other so we could hopefully start wrapping our mind around this idea that languages are all the same and hopefully kind of, we're seeing kind of Python's version of the same thing that Java does, which I promise you, C# does the same thing, Objective-C does the same thing, Swift does the same thing. Some of the older languages were kind of the trendsetter for this. So C and C++ is where all of today's things came from, and it's also kind of where those problems were originally introduced. Like in C++, we didn't have these like generic catch-all methods that people could override because it was kind of our early object-oriented language. So it was more about like, hey, let's just get it to work, and then we'll see what kind of problems bubble up, and we'll fix them later. And they did some stuff fixing C++. If any of you were C++ programmers or mess with it at all, you've probably noticed that when you go and look at C++ compilers, there's like 11 different compilers. I think in here, let me look at, if I go to the drop down, it probably doesn't have all 11, but it has a bunch. So let's see. So C++, C++14, that's 2014, by the way. 2017, 20, 23, Turbo C++, so these would be the oldest. Actually, I'm guessing these are probably the oldest libraries. So if you want to roll old, write old school C++, you would use this guy. In 2014, there was like a major update. They introduced something called the standard template library. If you're ever looking at stuff and it says STL, standard template library, that brought in kind of some built-in classes that are common to programs. And then they just kept updating it. And really, C++ today has a lot of the modern conveniences that the other languages have. It has like real strings that do stuff instead of like a hack C string thing or a standard template library string that nobody liked, blah, blah, blah. Yeah. So in any case, C++ was kind of its own little competition with itself, but it set up the foundation for everything we have today. So we've been diving into object-oriented programming. Again, just this organization approach to bringing our things into little classes, then creating instances of those classes, and then using them. Last time we talked about pass by value versus pass by reference. This idea that in an older language like C++, the programmer was empowered to choose how they want to pass stuff around. So we were empowered to make dumb decisions. Modernly, our computers have enough memory where it probably actually isn't that big of a deal, but it would be poor programming practice. So back then, you would have naturally probably passed all of your primitive types, ints, chars, all those guys, by value, which gives you a copy of it. Mess with it all you want, no problem. You would have passed anything that's an object by address. Those things way more than primitive types. Therefore, it'll be more efficient to give it a memory address, which is, I think we saw it's a 48-bit memory address. Technically, it's a 64-bit memory manager in modern operating systems, but usually 16 bits of it are used for just like super user administrator space. So user space, we have 48 bits of memory addresses. So we have 2 to the 48th power unique memory addresses. So big number of memory addresses. But in any case, it's only 48 bits, so it's only kind of like a little bit bigger than an int as a memory address. So that's a much lighter thing to pass than an object, an instance of a player, something like that. We might say maybe that weighs, I don't know, 200 bits or something. Our player as it stands right now probably weighs even less than that, but it weighs more than 48 is the punchline. Okay. So we used to be empowered to make these decisions. Modern languages do it for us. They just decide. Don't be stupid. We'll just do it. All right. We also saw last time, I think I showed some older languages. Objective-C is one of my favorite teaching languages because it forces you to do this. It shows you the most amount of inconveniences. So in Objective-C, whenever you have a constructor, the very first line of the constructor will be self equals object init. It calls the generic top level object. We looked at this guy last time, that all objects in our object-oriented languages come from this top level dude called object. Well, in older languages, Objective-C being a cool one with this, the very first line of every single one of your constructors would be to give a value to the keyword self, which is the same keyword we use in Python. C++ uses the keyword this, which means the same thing. But you actually gave value to self as the first line of your constructor. And what was it? It was an instance of object. Then following that is where you put in your custom code that enhances your generic object to be more than it used to be, right? You know, if you want to have additional fields, well, if you want to have any fields, objects don't come with fields. You could put those things in there. And then at the very end of your constructor, you would always return self, a pointer to this particular instance of the object. Modern programming has looked at this and said, you know what, if your first line is always this and your last line is always this, why don't we just take care of that for you and you don't have to worry about it? Cool. Quality of life stuff for programmers, but if you never saw it or never had to deal with it, it's hard for you to appreciate it. It's just like, oh, that's how coding works. Make some sense? All right. We talked about dunder methods, blah, blah, blah. This is our constructor. I won't test you on this, but we talked about this polymorphism thing. I think we were looking at the print stream. So we were following through Java's system.out.print stream and kind of decoding that. System is the name of a class. We kind of know because it starts with a capital letter. Out is the name of a field within this system class that happens to be an instance of print stream. So if I go into print stream, we see there's a bunch of methods all called println. And therefore they handle the different types that are built into the language. So we have a println for all the primitive types. And then we have a println, I think, for like character arrays and for strings, which are basically a primitive type. And then we had kind of our catch-all one of printing objects. And when we print out an object with println, what is println actually doing to print out that object? Remind me. It's calling a specific method of that object class. What's the method that the println function obviously calls for an object? The toString method, which is equivalent to the underscore underscore string or underscore underscore str underscore underscore dunder method in Python. But effectively it says, look, I know every single object knows how to provide for me a string representation of itself. Whatever it has decided makes the most sense. The default object says, okay, you want a string representation of me? I'm going to tell you what I am, followed by an @ symbol, followed by my memory address. That is the best I can do because I don't have any fields. I barely have an identity. All an object has is a couple of methods for communicating with the operating system and a memory address. So if you ask a generic object, give me your, give me your toString, a string version of yourself, that's the best it can do. But if we wanted to make our own version of that, we want our objects to do something a little bit more. Go back to our code here. We saw here for our player, which extends object, and remember, this guy is also hidden from us. Older object-oriented languages force you to say, I'm making a class called player, and he comes from the top-level class called object. Every single class that exists in an object-oriented language at some level in its lineage comes from object. So we really don't need to rate that. It can be assumed by the language, and modern languages do assume that. But I promise you it's there. All right? So we have a player which is an object. So it gets everything that objects have, including that toString method. So right now, am I calling toString? Calling get name. Let me just go down to, well, here. My constructor still printing stuff out? No. So the very first thing we're going to print, we're creating an instance of player right here. Then we're going to print out the value of that instance. And what it's going to do, so we're calling the version of println that takes in an object. So this is the println. That takes an object as a parameter. And what does it do with that object? It just calls its toString. And the default toString, just change that to 2 strings here so we're not actually overriding the original. Oh, actually, if we want to, there, I will throw a Lippmann typo in there. All right, so there's definitely not that method there. So if I go ahead and call this again, instead of it printing out player followed by that player's name, it's going to call the 2-string version of this guy, which is going to give us the name of the class followed by that symbol followed by the memory address. This guy right here. That is what the generic 2-string method that we get from object gives us. That's what it does. All right. If we decide, you know what, I want my 2-string to do better than that. I want println to print out instances of my player looking more reasonable than that. And the proof of this is when I've asked questions in the past, when I'm like, oh, what will print out here? The answer is always memory address, but the default answer that pops into your head is, oh, we'll just print out Mike. That's what the player's name is. That's what makes sense. It's got a player that's Mike. If you want it to work that way, you have to write it to work that way. So now that I've written my own version of 2-string, this is a scoping rule thing, here inside of system.out.println p, it's going to call that 2-string method. So now we get a version of 2-string that doesn't print out the memory addressy thing anymore. It prints out what we told it to print out.
Same for Python.
Now, all languages. Every object-oriented language does this.
Can we see like an example in Python?
Yeah.
How like calling the 2-string method, I guess, would work.
Well, I mean, we don't actually call it, but let me just finish up this example, then we'll do the identical example in Python. So, and just to prove this point here, I'm going to dump these last 2 guys. So we'll see these are both going to print out the same thing. Okay, now, but my question is this version of println the same version of println as this guy? Or am I calling 2 different versions of println? Okay, the first version I'm calling takes what kind of parameter? An object. The second version I'm calling takes what kind of parameter? A string. All right, so they both ultimately do the same thing. We see what the output is, but this is our evidence that, oh, this guy right here is just calling that 2-string method. And if we also want the fancy memory addressy thing, we can come up here to 2-string and we can tack on super.2string. And now our thing also gives us the memory addressy thing, because that's what our parents' 2-string method gives us. So if I want to do my own thing, but I also want my parents' thing to do its thing, I can call upon it. Super is how we call upon our parent. Don't worry about that too much right now. We're going to be working with inheritance in several weeks, but just take it as this is how object-oriented languages are built. Go ahead.
Like opens the parentheses and then based on what's in there decides what it is.
Correct. Yeah. So the question was, when we are calling println right here, which version of println gets called? And just to kind of show you, what was it, print stream? Just to remind you, we come down here and we see we got a bunch of printlns. Okay. Now, no 2 of these printlns takes the same input. They all have either a different number and or type of parameter. In all of these, it's a type. All right. So we have one that takes nothing, that just prints out an empty, kicks it down a line. One that takes in a Boolean, one that takes in a char array, a double, a float, an int, a long, an object, a string. Whole bunch of versions of these. So when we call println, the compiler figures out which of these are you actually talking about based on what you gave it. If you give it an object, it'll call the object one. If you give it a string, it'll call the string thing. If you give it an int, it'll call the int one. And each one of those may or may not be implemented substantially differently. I'm sure the println object and println object probably calls the strings version. Something along those lines. All right. That's just like pressing enter. Nobody uses it. Most people, if you're going to kick it down a line, they would do this. They would just put in double quotes like that. And that will print out nothing and then press enter. As opposed to, you notice when we were looking at the documentation, there's a whole bunch that are just print instead of println. So if I show this should print out the object with our toString. This should print out nothing and kick it down the line. This should print out nothing but keep it on the same line. And then this should add to the end of that line, Mike, and then kick it down the line. So println, the ln, is print something, press enter. The ninja move, it does those two things. Print, just print something and leaves the cursor right there after the last character in whatever you printed. So we will see, actually, if you want to, I'll just put some spaces in there just so we can see that it kicked it, didn't, that it didn't press enter after that one. So you'll have Mike on the same line. Indented a bunch. All right. Make some sense? These aren't things to memorize. We're probably going to be bouncing back and forth between Python and Java for a little bit. Then we're going to be switching fully to Java in preparation for encoding 2. Well, actually, mostly I'm doing Java to go against his wishes, because he said anything but Java. But actually, it's encoding 2. I mentioned we're going to be using Unity Game Engine. So again, I'm teaching the perspective that coding is coding. That's the skill set. The language doesn't matter. So we're dancing all over the place, but hopefully you're seeing, oh yeah, it's just the same crap.
So we could be Java coding.
You'll be learning C# encoding 2, which is Java after a lawsuit. It was born out of a lawsuit when Sun Microsystems sued Microsoft for stealing Java. But Unity Game Engine allows us to create visual video gamey type things. But the language that it uses for scripting is C#. But we're still going to be learning programming concepts. This is kind of like, if any of you have a pet, like a dog, you hide its medicine in the food. Because when you see text-based outputs, it's boring, right? It's like, oh, well, I came here to learn how to write Xbox games, something like that. Well, if you're a console gamer or even a PC gamer, I'm sure you have seen some game at some point launch where it has a big Unity thing at the beginning. They wrote that with Unity Game Engine. All right, so we're going to be using that in coding 2. It's not that difficult. In fact, in many ways, it's easier because more of the stuff is kind of done for you, but it follows the same object-oriented kind of approach, and it uses a C# language, which is almost identical to Java. So it changes from our Python mindset a little bit. Have you tried Unity? Why don't you like it? You just suck at it?
No, I just like other engines better.
Well, what engine? Unreal?
Godot.
Oh, come on.
It's so much better.
It's 2 seconds old.
Doesn't matter.
Oh, okay, okay. No, I can go with that. It has, because it's come out so much more recently, it's taken things that it saw in these other game engines that have been around for a long time and said, how can we make this better? So you're right. Unity is kind of like the C++ of game engines. Whereas Godot is like the Java of game engines, a much newer language, and they said, hey, some of these things are just unnecessarily complicated in Unity. Unity's still way better than some of these other older languages, but so it's trying to do that, but there's not nearly as much material out there for like tutorials and documentation and stuff like that. But you're right. If we fast forward 5 years, we'll probably be using that in here. Maybe even 3 years.
But like Unity is like Windows, or Windows like Unity, it keeps slapping stuff on.
Come on now, we're gonna throw Linux.
No, that's true. I mean,
Because-
all of our language, and we just saw it with C++. I mean, we're not off topic here. I mean, we saw it with C++ here.
No, but with the Unity, you can't update the engine for your game, or everything breaks.
You're right. And the same thing happened here. C++ came out, you wrote a whole bunch of code in C++. Then when they bolted on the updates for C++ 2014, all your stuff broke. Same thing happened with Python. Everybody was writing code. The last version of Python 2 was Python 2.7. If you had projects written in Python 2.7 and they came out with Python 3, all your stuff broke. You had to go back and update it for Python 3 or scream really, really, really loud. And then the Python people also maintain the path for Python 2.7 so you could still have security updates and stuff for it. So for a long time, they supported both. 2.7 you can still download it, but they're not supporting it anymore. So everything's Python 3. Now we're at 3.18 or something. You know, we've many versions into Python 3 now. But this is just history repeating itself. You know, so your stuff broke here. Your stuff broke here. Your stuff broke here. Maybe a little bit less between 20 and 23, but your stuff was still breaking. History in normal computing. When Apple first went from PowerPC processors to Intel processors. You know, IBM was making their PowerPC processors, which were a different architecture. They're a RISC architecture. And Apple all of a sudden said, hey, everybody else is using Intel. We're having problems with IBM creating our chips, so we're just going to switch to Intel. Everybody else is cheering that, but we learned in here that when you use a compiler, compilers are targeting two different things. The operating system and the architecture. You need both of those things. Remember when we looked at the Hello World program in Linux? We saw how even that was using power tools. It was calling system calls inside of the operating system. All right, so when Apple first released their Mac, which was still running their version, was it OS 9 quite yet? It was OS 8, I think, at the time. But you know, they had just released their operating system. No, it was OS 9. It was OS 9. So they released their operating system, OS 9, using PowerPC. Then all of a sudden they said, okay, if you buy a computer tomorrow, it's going to have an Intel chip in it. And still running OS 9. Well, all your software that's running on your Mac was compiled for PowerPC architecture running on OS 9, not Intel architecture running on OS 9. So none of your crap worked. Now, that was a point of potential failure for Apple, but they survived. Dodged the bullet. Why? Well, we could say Apple users are drinking enough of the Kool-Aid that they'll, you know, Apple can do no wrong, right? You know, something like that. Where's my Windows thing? I run Windows and stuff on here. Oh, but in any case, so I run multiple operating systems on this thing. So I'm not married to Mac OS or anything. I also have Linux on here. But so they dodged the bullet, no problem, right? Several years later, they decided, you know what? OS 9 is a really crappy operating system. Because back then you had the Mac people bragging about how much better their operating system was. It was junk. You know, Windows had already gotten to the point where it had a start button. When Grandpa opens up the computer, what does he click on? Well, it says start. I'm going to click on start, and it shows you all your crap. Apple doesn't have that. There's no start button. You had to open your hard drive, go find the application folder. You know, it sucked. It wasn't any good. So Apple said, okay, well, we're going to create a brand new operating system. So that's when they came out with OS X. OS X was a whole different operating system. It was based on top of Unix, not on top of Apple's proprietary kernel. So now all your software had been, at that point in time, had been re-released with Intel binaries. So it ran on your Intel Mac with OS 9. But now they said, okay, now we're going to switch OS 9 on you. Okay. Here's OS X. It's so much better. Okay. Whole new operating system. All your crap just broke. Okay, so what did they do? They shipped OS X with a virtual machine. How many of you have ever used a virtual machine like VirtualBox or Parallels or VMware? You used it to like run a different operating system. So maybe you have a Windows machine, you've used it to like boot Linux, something like that. Okay. Well, the first one of those that was kind of commercially was already installed on OS X when those first Macs, it was called the Blue Box. And what it did is it launched OS 9 so that you could run your applications that used to work yesterday. So you were running your applications inside of a virtual machine, which made them slower than they ever were before, just so they kept running while you waited for all the people to re-release their software to work on OS X. Apple dodged the bullet again. So we've seen this happen over the years, and you're right. Godot will be top dog at some point, and then it'll get supplanted by the next thing. Might even be Unity. Unity comes out with a brand new engine, yada, yada, yada. I mean, we should have low expectations with Unity at this point since Microsoft absorbed them. So it's like, where's this going to go?
Bad before that.
Huh? Yeah, no, I mean, you're not wrong. But in the early days of Unity, it was the only thing doing that kind of stuff. Unreal was a proprietary game engine for the game Unreal. It was what the company built internally. And this is all to be expected, right? We hope that we keep getting new versions of software, new competitors that either force the old guys to keep up or they get stomped on and you move on with life. So we're just seeing history repeat itself. So, I mean, I agree with you, but I'm still doing Java to punish you. So, all right, let's not forget about her question. So you want to see some of these examples in Python. Okie dokie. Let's see. Before I jump there, are there any questions about this stuff? Not memorization stuff. You don't have to memorize all this crap. I'm not going to ask you to break down the whole println thing. I just want you to appreciate the organization of object-oriented languages. This is how they work. Okay? All right, so I think I'll need to start a new project to do this. Changes you, okay, fine. Let me save this just in case we want to bounce back. Java, examples, let's just go with that. All right, so now we'll create a new project. We're going to choose Python 3. I'm lost. My eyes are not very good. Hold on.
Right.
Got it. So, no, it's under Java. You missed the. Oh, he's blocked it out. There's PT Java PTSD. I look forward to this. All right. First thing we're going to do though is we're going to doctor up our Python program here. Okay, because what they give you as your starting point looks a lot like a script. So if you've ever seen like a JavaScript program or something, things that run inside of websites, it's not an organized structure. It's just like, hey, start on line 1 and just keep kicking. Kind of breaks what we're looking at from understanding scoping and stuff like that. So what we're going to do is we're going to go ahead. I mean, we can run this right now. We see it works, no problem. But we're going to go ahead and put our print hello inside of a function that we're going to call main. Now, if I run this right now, what's the output going to be? Going to be nothing. Okay. Nothing called main. I defined a function and I never called that function. Now, leave me alone. Have you seen that new feature with the new OS where it screens the calls for you? It'll talk to the person and then, who are you before I put you through? So I get like a whole text thing telling me, I still always ignore them. But I at least find out who they were. They're always trying to sell you a loan because I run a lot of businesses trying to give me loaning my company's money or something, and they have new rates. Every single day they have new rates. All right. Now, I can come down here. Oh, sorry. Go ahead.
Why doesn't this give you like an error instead of the
Because it's not an error. I mean, there's no syntax problems with this program. So here we're going to just write a comment here. Program starts here. And we're going to say function definitions start here. All right. So we currently have nothing in the program. So nothing's giving instructions. Yeah, we have this ability up here, just like everybody in here has the ability. If I give you two, relatively small numbers, you can add them together. If I say 3 and 5, you can come back with 8, right? But until I call upon that ability, you're not just going to be in the middle of the class, just spurt out a number, right? So main here is an untapped resource until we call it. And right now, our program doesn't do anything. If I wanted to call main, so that's why it's not an error. It isn't an error. It's just us not doing anything. We're just sitting there twiddling our thumbs. I can call main like that, and now we'll get hello world printed out because now my program says, call upon this ability I wrote. Now, the issue here, and actually we can probably say this is good enough for what we're trying to do here. We probably don't actually need that extra if statement. But let me go ahead and put it in there so I can connect it to those Dunder methods we talked about. So what we had been writing is this little if statement that said if this is a Dunder variable, let's say, called underscore underscore name underscore underscore. So there is a variable available to us automatically called name with underscores on either side of it. And we're asking, does that variable currently contain that dude, main? If it does, then I want you to do this stuff. And I've advertised that all programs begin and end with main. So it shouldn't surprise us that when a Python program launches, it indeed sets underscore underscore name underscore underscore to underscore underscore main underscore underscore. Go ahead.
Like the internal self-referential thing, the same way self is for individual, like within that function. Represent the entire code.
No, it's the runtime of Python. So when the Python interpreter starts, it's going to start with the goal of calling something called underscore underscore main if the user wanted to make that differentiation. Because there are other Dunder things that you can call that might do other things. I actually can't come up with a great example of the Dunder keywords like this right now. I can look it up if you want to email it to me or just Google it. Would be very uncommon. It's not something that actually happens, but there are other options. Name could be something else. If some other program called your Python, wanted to call your program in the way you call a Python programs have to run within the interpreter. It's an interpreted language. So if you had program X want to run this Python code, it would have to tell the Python interpreter to run this code. And it might say to do that by setting some pre-variables to do maybe something else. So it's possible they might have 2 or 3 different starting points there where they set underscore underscore name equal to 2 or 3 other things. Maybe there's a version of it that is when a normal user is using the program. Maybe there's a version of it that works for administrators or something like that gives you more options, that kind of stuff. So that would maybe be your opportunity there to do it. I would generally say that Python isn't commonly used for those kinds of problems. We might be having a different discussion in 2 or 3 years since Python, not that it's had a resurgence, Python has been popular for a while. But now with AI just being everything, Python's what you use for AI. It's all the libraries are written for it first because AI grew out of the machine learning group, which grew out of data science, which isn't computer science, but still is a programming based thing where they're like, hey, give me a bunch of data. I want to visualize it. So that's how I'm programming. I'm telling this computer to do different things. But those folks were already used to using those technologies. Yeah, so as I have this written right now, I'm telling you when I hit play up here, wherever that is, when I hit, where's my play? Oh, yeah, see, my eyes are terrible. When I hit play up here, what it does is it calls, sets name equal to main and calls this. Now, if I don't ask the question and I just say, no matter what happens, you're calling main. This isn't you're not conditionally calling main, you're calling main every single time. as opposed to me saying, okay, you're going to conditionally call main only if the value of name equals that. So we see it run, but if I have a typo, and I say, well, only if name is equal to underscore main underscore. I didn't put the second underscore there. Different string. Now it's not going to run that guy. Name wasn't equal to that. So it only conditionally did it. It asked the question and said, nope, doesn't match. Move on. What else is in the program? Nothing. Program's empty down here. All right, make some sense? All right, so I'm going to continue to leave this in here like this, maybe to reinforce that main thing, and also just so you don't, the dunder stuff doesn't fall out of your head. Trust me, it is stupid, but but it's a thing, and it's part of Python, and Python is probably more part of our future than this dumb game engine thing is. One of these days, I'm gonna get him to rage. Just trying to break you and then build you back up. All right.
Oh, sure.
Well, we'll see. Challenge accepted. All right. So we want to create a kind of similar type thing and see some of those examples we did, but we want to see it in Python. So I'm going to go ahead and I'm going to create, our class was player. Is that what we called our class player? So I'm going to create a class up here called player. Actually, I'm going to go ahead and put it in a separate file since I want to start transitioning to kind of having our classes in different files. Have I shown you that in Python yet?
Yeah.
Okay, so let's just do that quickly. So I'll create a file called player.py. In Python, they don't care what you call it. Other languages make you name stuff. The name of the file has to match the name of the class. Python doesn't care. But probably match it to the name of a class. All right, then inside here, I'm going to say class player. And we're going to define underscore init. All right, remember, this function right there is one of our dunder functions built into Python. This is our constructor. So instead of like in Java, where our constructor was called player and took name as a parameter and didn't have this extra self thing in there because object orientedness wasn't a bolt-on, this is what we call our constructors here in Python. All right, so we'll set the name there. So let me just stop here for a second. Python. Okay, we'll go with that. All right, so now I'm going to go back here to main. And we're going to go ahead, we're going to create a instance of our player. Name Mike. And then we'll print out P. What's the output of this program going to be? Tricking you.
Error.
Error. Okay, why is it an error? Never heard a player. This is our scoping thing. Where do you have access to stuff? Python does not know about this dude. If I had written it up top in the same file, then it would be part of the local scope or the global local scope. But I didn't. I put it in another file. So we need to import it. So we're going to say import player from player. Probably should have named it the same uppercase, but whatever. All right, so now we'll have access to player. In fact, let me just show you what that error was real quick before we actually put that in there. All right, so right here it says name error, name player is not defined. Never heard of it. And make sure you get used to reading your error messages. I think I've said this before. When you get an error message, beginning programmers tend to just start randomly changing stuff. When the error message may have been something very simple, like you forgot a semicolon or whatever. Now you've gone through 50 permutations of your program when you actually had the right answer minus a semicolon 3 hours ago. Something like that. Read the error messages. You will get better at interpreting them over time, but they're usually fairly self-explanatory. I Eventually, when we get to a little bit more complex program, I'll introduce the debugger to you. Early on, what computer programmers tend to do is when our program's not working that well for something, we'll include a bunch of like print statements. We'll say, I made it to here, then I made it to here. This is the value of this variable here. It's breaking later on, but I want to make sure it's still good here. So you can kind of narrow down where things are going south. But you're having to put a whole bunch of extra crap into your code. A debugger lets you kind of put stop points in your code, and your debugger goes through the program and pauses there, and then you can just look at the list of all the variables and what their values are. It just kind of makes that easier for you. Not worth doing it for a tiny program, but we're going to pretty quickly ramp up to our dungeon crawler, which is going to be a bigger thing. All right, so it's yelling at us now. I'll go ahead and put that line back in. So now, did you mean to use from? Yes. From player, import player. I just had them flip-flopped. All right, so now it's heard a player. I print out the value of P. We see that it gives us something very similar to what we saw in Java. Here's the class name. Instead of the @ symbol, we just spell out the word @ and then here's the memory address. It's the same crap, right? And that definition is defined inside of an object called object. Maybe it's an uppercase O, maybe it's a lowercase o. I'm not sure what it is in Python. So inside of player, the reality is that this guy comes from this thing called object. And we'll look at inheritance later on. All right, so for right now, we're stuck with this idea of our toString isn't very useful. We maybe want the player's name to pop out. So what I'm going to do is inside of player, I'm going to go ahead and write a function called __ string. And still say self. And we're going to go ahead and return self.name. I'll save this, and this looks like pretty reasonable syntax. Let's see if I got it right. Yep. Okay. So what we did here is we wrote Python's version of toString. We wrote our own more local version of toString called __str__, stupid dunder methods. It's only stupid because I don't like typing all the underscores. I make a lot of, I don't see keyboards very well. Yeah, so in any case, here's that example of that. If I want to include my parents thing, is parent in, is it super in Python? Super dot __str__. See if I have to pass in the self there. Doesn't like that. Do I have to pass in self? Yeah. All right, so here's that same example. I wrote my own version of string. What's this guy going to return? Well, before I just had it returning the name. Now I'm tacking on to the name the same thing my parent did for that __ string. This, yeah, you're seeing it right here. That right here, what I have highlighted is this part of the code. And that's being concatenated onto this part of the code, which just produced Mike, the name of that player. All right. So are we convinced that Python and Java are basically built the same? It's an object-oriented language. This is how they work. When you take the language theory class with me, if you do the, well, it'll be me or Blade if you do the undergrad one. He's good. I taught him the stuff, but we write an object-oriented language in there. And you'll see this. I wonder what that was for.
You can really need function from that class, or can I just use if name is equal to underscore? I mean, they,
You mean, do I need this line?
no. Function.
Well, you don't need it, but if you don't have the function main, this won't happen. And
We want-
I would say, yeah, so let's go this route. Yes, you need it if we want Python to behave the same as other modern languages. Yeah, because we saw last time, if I define a variable in here, like hello, and then I try to print S in here, it knows about it. So main is its own function. I didn't pass S here, did I? So I didn't give it to it as an input. I didn't define it inside the function. So why does this guy know about this variable named S? He knows about it because I defined it as part of the global scope. And typically global variables aren't a great idea. It's certainly not warranted in this case. So it's hard to kind of explain variable scope when you're almost encouraged to create global variables in Python. So in order to make this work the way that other languages work and enforce it for us, we're not allowing you to do that. Or even if you did do that, I guess you could just choose not to call those variables here, but really you would never do that. And all you're doing is the one thing inside of this if statement. Call this function called main. So really it's this function that starts the whole program rolling. That if statement just kind of hands it off, but only if whoever called this wants main to happen. Underscore underscore name is equal to underscore underscore main.
Also, what's the difference between, the underscore string, the understring, and then just doing display? Or is it
Well,
only-
There, well, here, I mean, so we see what this is doing right now. Let's just put it back to where it was just putting the player's name rather than the parents thing. All right, so we'll run it. We'll see it just says Mike now. Now you're saying, well, what's the difference? What if I just call this display? Yeah, no, I'm with you. So if I just call that display and I go back here, what's going to print out now? No, not Mike, because it's the print function calls that object's underscore underscore string underscore underscore function. That object has that underscore underscore string function because it got it from object. We've no longer overridden it. We haven't written our own version of that. Instead, we chose to call it display. Nobody's calling display here. It's not automatically calling that display. So now we're going to get the memory addressy thingy. If we wanted to print this, we would have had to say p dot. Actually, we wouldn't say, well, we would actually do this. This is a bad version. You wouldn't probably call this display since technically it returns a string, doesn't display anything. But if I want that version of the function to get called, I have to ask for it. Python's not going to ask for it automatically. What Python does automatically is call that string dunder function. Make sense? That's just a Python behavior. Just like Java has the same behavior. If you try to print an object in Java, it calls that object's toString function by default. So you can choose to take advantage of that, or you can just say, look, I'm not going to mess around with toStrings. I'm not going to mess around with dunder str. If I want something to display, I'll write a display. It's not the end of the world. But in fact, that's what I usually do in languages. I rarely override toString myself. It doesn't really solve any sort of major issue situationally, maybe sometimes, but it is how these languages work. All right. Did that cover the examples you wanted to see? Okay. You just switch this back to str. Oh. I put an on-purpose bug in there and he didn't catch it.
Sorry.
Apologies not accepted. All right. So I know we kind of beat a dead horse there, but I mean, are we good with these things? So we feel comfortable enough with objects, but let's start doing stuff with them. All right, so because we're going to need it in our dungeon crawler, let's go ahead and write our dice roller. That now, I guess we could put it to a vote. Do we want to write our dungeon crawler? Do we want to write our dice roller in Python? Or do we want to write it in Java? Python? I am going to transition over to Java unless somebody has a really good example, a reason not to.
Java.
You want to write it in Java? No, really, you should be able to read it right away, right? Yeah. So, I mean, I'll do whatever you want. I don't care which of the two languages we work with, but Java will prepare you better for C#. But you're already seeing they're the same thing. All right. So the first thing you want to get out of your head is, oh, we're not actually choosing something different. We're just using a different syntax. It's code. Still the same thing. But this will mean that you'll no longer be able to use the collab. Collab is a Python thingy. So you'd want to use online GDB like I'm using here, or if you want to install your own local, Eclipse is kind of the popular, one of the popular Java IDEs. NetBeans from Sun Microsystems, well, I guess Oracle now is another one. There's several other Java IDEs now that have some of the AI stuff built into it or whatever, but if I were you, I would use onlinegdb.com like I'm using it. That way you're working with raw code and practicing rather than having these things do extra crap for you. But
So, I'm going back to the display method. When we call display, it doesn't override toString. It just,
display and toString are different names, right?
yeah, but I'm just saying, like, when you call the method display and you're asking it to do the same thing that a understring would.
Yeah, I get you.
You're not really replacing the two strings.
Right. So we'll make it back to display here. And then I'll do two things here. I'll call P and I'll call P.display. We certainly saw that it will, if we want display to get called, it will, you definitely need to call it. But you're asking, well, does it also break the other string thing? Because is it overriding it anyways?
So, like, what is it doing to the actual two strings?
It's not doing anything because we didn't write it with the same name. If you want to override a function that your parent has, so in this case, our parent has __str__. If we want a more local version of that has our stuff in it, we have to name it the same. So even though display right now effectively does the same thing that we did have in __str, it's not the same function. So you'll see that these two guys do two different outputs. This one's calling __str. This one's calling our version of display. If we rename display, all we're doing is renaming display. And we come back here and I run this, what's the output going to be? Tricking you again. I'm calling display in here. Have we written a thing called display? No, it's going to scream at us, right? Yeah, I've never heard of that dude. But if I tell it to print out the object, the default behavior is to call the __str, and we have written our own more local version of that does something, we can call it better than just a memory address. So there's our, if you don't, the backup plan is object gives us the ability for print to be able to print it out. It gives us that __str that just has the best I can do as a memory address, deal with it or overwrite it. It's up to you. All right, so let's start another project. Do I click there? All right, we're going to shift this over to Java. All right, gives us our basic class. One inconvenient thing I would say in online GDB, and it's not incorrect. But notice that it names this default file main.java with a capital M. Therefore, my class name is main. There's nothing wrong with that, but I don't really like it working that way because this main and this main is not the same thing as this main. A class can be called main, but when I say all programs begin and end with main, it's the main method or the main function that gets called first. So this will work perfectly fine. If I run this, we'll get our hello world out. But just to kind of dive us into Java here, I'm going to rename this guy. Come on, I can do it. I'm going to name this guy driver. You can call it whatever you want, but I like to name my main file driver. If you buy a new, for PC gamers, you get a new graphics card, and you first put it in, it loads the default VGA driver that, like I just spent $3,000 and I'm only getting 640 by 480 resolution. What do you need to do to make it look good? Install the driver. Install the software that drives that hardware. So this is a file that drives the rest of our program. So I do that as a naming convention. And that is actually a Lippmann thing, not something you'll necessarily see in books. Do what you want. I would just encourage you to differentiate it from main so you don't get those two things confused. Now, if I run this guy right now, it's going to scream at me again because in Java, it wants your class name to match your file name. So it's going to say, hey, look, you just changed that guy to driver. Now, you got a class name main. Do you even know what you're doing, dude? So we need to change this guy here to driver. Now he'll be happy again. All right, so now when I say all programs begin and end with main, the only thing that says main on the screen right now is our main method. All right, and I know there's a whole bunch of extra crap here before it. For right now, let's just leave it alone. All right, I think we had mentioned this one other time. This is for command line arguments. We will talk about this static keyword, just not right now. Main returns nothing. Remember, Java is a strongly typed language as opposed to Python being a loosely typed language. So as a strongly typed language, every single one of your functions has to advertise what kind of value it's going to return. Or if it's not going to return anything, its return type is void. We just are required to mention that. In Python, we have an intention of what our functions are going to return, but it doesn't require us to tell the interpreter about it. Yeah. So anyways, and then this public thing, we talked about public, private, protected a little bit. Main has to be public in Java because it has to be accessible by the Java virtual machine. So it needs to be, it's in a different directory than this guy. I think last time we talked about that the default security level on our stuff is package level, which says if it's in the same directory as this. Well, typically the Java virtual machine, the computer written in software that knows how to run Java programs, because Java kind of sits between purely compiled programs and interpreted programs. It behaves like a strongly typed compiled program, but it actually doesn't run directly on your PC's hardware. It runs on this Java virtual machine, which mimics hardware, mimics its own computer, and then translates or interprets that to the equivalent instructions on the actual hardware of your computer. So what they do is they port the Java virtual machine for Windows, for Mac, for Linux, for Android, for iOS, blah, blah, blah. All right. So idea here is that the Java virtual machine has to have access to your function called main. It doesn't live in the same directory as your code. Therefore, we have to say everybody has access to this guy. All right. So I'm going to go ahead and create a separate file here. And this is going to be for my dice. We had a class was called dice. We're going to say dice.java. And we're going to say public. This actually doesn't have to be public. It's pretty common practice to make it. Actually, let's leave it off for now, just so it really matches up the Python closely. So we'll say class dice. We only intend to call this from within our project, so this is perfectly fine. So we're going to have a class called, oops. Yeah, that's anywhere close to what I was going to do. Crappy. Why does it think I want to say that? All right, so class dice. Notice that all those times we would have put a colon, pressed enter, and it just indents. You put curly braces now. And indentation is no longer important by the rules of the language. It's not going to yell at you if you don't indent, but I'll yell at you if you don't. Indentation, that's the one good thing about Python, is it forces you to have well-structured code. And that is something that beginning programmers struggle with. So if I was going to point to one thing that Python does that is better than other languages from a teaching perspective, it's that. All right, go ahead.
You want the starting bracket to be on the next line.
I like it that way. What he's talking about is it's not uncommon for you to see it like that, where the opening curly brace is up on the same line as the other thing. Bottom line is these languages don't actually care. You can put your whole program on one line, but that's not going to be very human readable. This is fine. You'll see plenty of examples of it looking like this, but this doesn't exist to be good for programmers. The reason this exists is years ago, all the code was inside of like textbooks, not on the internet. Well, this saves a line. And every single time you write a function, if you have that one curly brace on the top line, you save a line. You can fit more stuff on the page. That's where this came from. But lots of people copied code out of books and then manipulated it and stuff. So it became a standard. I don't care, but I encourage you to do it that way. I think it kind of you'll see in the end, but I'm not going to, well, I'll take points off of you, but not everybody else. You will find plenty, at least half the programmers in industry will do what you're suggesting. We'll put it up on that top line. So pick your poison. Doesn't matter to me. All right, so now we need our constructor for dice. Go ahead. Oh, you could choose to. I'm going to give you the code for it as your starting point and then have you convert your Python to this. All right, so now we need to have our constructor. Now in Python, constructors are underscore init, and here it has to be the same name as a class. So I'll have public dice is the name of my constructor, and this guy is going to take in a number of sides because I'm going to be able to, I want to be able to make a 6-sided die or an 8-sided die or a 20-sided die, all these different things. All right, so now inside of here, I want to set a field associated with my class to remember the number of sides, because sides is a local variable to this constructor right now. In Python, we would say self.sides is equal to sides. That's what we would say in Python. Now, Python, because it's a loosely typed language, did not require us to have previously defined the variable called sides. Java does. So at the top of our code here, we would have had to say, I'm going to make it private. Well, I'm just not going to, we'll come back to the private thing. I'm going to say int sides like that. And now we're saying this version of sides, variables resolve to their most local definition. So when I say sides, it looks locally and says, is there any variable in this scope called sides that I should be referencing here? And there is. So sides right here references this guy. But this version of sides has something before it. Something that is a lot, we're kind of giving it like the full path to sides. We're saying this guy's owned by this particular object, so you can find him up with his fields. But in Java, it's not self, it's this. This dot size. Ay, ay, ay. Like that. All right. Now I'm going to create a function called roll. And roll's job is to roll a value between 1 and the number of sides. All right. So in Java, we have several different ways of creating random numbers. One of them is to create an instance of something called random. So I'll say random r is equal to new random. And then I'll say return r dot next int, just for right now. I'm going to leave it like that for right now. All right. Now, I'm not even using sides at this point, right? I'm just getting a random number. Now, if I run this right now, well, it's going to yell at me because it doesn't know about random. So at the top here, I need to say import java.util.random. Just a class that lives in this library of Java that has a whole bunch of utility classes in it. There's another one called java.math that has a whole bunch of mathy stuff in it, like cosine and yada, yada, yada. All right, so the way we get a random number in the range of all random numbers is saying r.nextInt. Okay. So now I'll go back to, actually, I'm going to go ahead and call this our dungeon crawler. All right, so now inside here, we want to go ahead and we want to say dice, we'll call it D6, is equal to a new dice, and we'll pass it 6 for 6 sides. And then let's create a quick little for loop for int I is equal to 0, I is less than 10, I plus plus, and we'll go ahead and print out d6.roll. So we created an instance of our dice class up here. Pretty similar to how Python does it. Then we write a loop. This is going to go through 10 times, and we're going to call our roll method those 10 times, and we'll get 10 numbers in the range of integers between negative 2.1 billion and positive 2.1 billion. Make sense? So I'm going to give you this as a starting point. And for Tuesday, take your working, your code that you did for the previous assignment, your dice roller, and finish bringing this guy up to the same spec. All right, make some sense? Take a little practice, but hopefully through this, you'll see, oh, it's basically the same thing. All right, questions, comments, concerns, bribes? Yep. And I will give you a link to this whole project. So you'll have access to this and can run it and all that stuff. I'll put it with the assignment. Give you the link. All right. And I'll send out an announcement here in a few minutes as well with that invite for it, for the thing at the lab next Wednesday, the presentation thing. Please get that on your calendar.